been told the torque T produced by a motor is given by T is 1000 BI. The torque T produced by a motor is given by T is equals to 1000 BI. Nm. Newton, that is force, isn't it? Where B is the magnetic flux. Where B is the magnetic flux. It's the magnetic flux density, and I is the current. The torque T produced by a motor is given by T is 1000 BI Newton meter, where B is the magnetic flux density and I is the current. Full stop. Then proceed. At one instance, B was 50 Tesla. B was 50 Tesla, while I was 10 amps. While I was 10 amps. Are we together? At one instance, B was 50 Tesla and I was 10 amps. Then you've been told to apply partial derivatives to approximate the change in torque. You've been told to approximate change in torque if you've been told to apply partial derivatives to approximate the change in torque if B rises by 2 Tesla, if B rises by 2 Tesla, and I drops by 3 amps, and I drops by 3 amps. Are we together? Now, if you look at this question, you've been told the torque T produced by a motor is given by T is 1000 BI Newton meter, where B is the magnetic flux density and I is the current, isn't it? Then they have gone ahead and said where B is the magnetic flux density and I is the current. Then they are saying at one instance B was 50 Tesla and I was 10 amps. Apply partial derivatives to approximate the change in torque. They want you to find the change in, this is what they want you to approximate, isn't it? The change in torque. If B rises by 2 Tesla and I drops by 3 amps. Now when you are looking for the change in torque, meaning torque should be a function of something which is changing, isn't it? So from this equation you can see torque is a function of B and I, because it is the magnetic flux density and the current which are changing, because you can see the current is dropping and then the magnetic flux density is rising, meaning the torque is a function of the magnetic flux density and current, because these are the variables, they are the things which are changing, isn't it? Yes. Are we together? Meaning what you are looking for is what you make the subject of the formula, in other words. Are you seeing that? And we are looking for the change in torque, and the torque is already the subject of this formula. T is already the subject. Meaning if they were looking for the change in I, meaning you make I the subject of that formula, isn't it? So they wanted the change in torque. So Once T is the subject of the formula, so T is going to be the function of the other variables. And which variables do we have? We have the magnetic flux density to be varying, to be rising, and we have the current to be dropping, meaning those are the two quantities which are varying. They are the variables, isn't it? So if you now construct a T to be a function of B and I, meaning the total derivative dt, you differentiate T partially with respect to B, isn't it? Are we together? You differentiate T partially with respect to B, then you remain with dB. Are we together? Is that okay? Then it is plus, you do what again? You differentiate T partially with respect to I, isn't it? Is that okay? You differentiate T partially with respect to I, then you remain with the I. So you see, you have the total derivative, isn't it? So from this total derivative is now what you use to get what do they want. So what do they want from this total derivative? They want the change in torque, the change. They don't want the rate of change, they just want the change, isn't it? And you know the change is denoted by that, isn't it? So it means when you want the change in torque, the change on torque will be noted like this, isn't it? So it means where there is this B, you substitute with this B. Are we together? Where there is this B, you substitute with this B to get the change. Are we together? So it means anywhere you see this B, you change it with this B for change. You change it with this B to change. And you found the formula for change. They are just interested in change and not rate of change, isn't it? Are we together? So it is that total derivative which is guiding you to get whether you are looking for change or you are looking for rate of change, isn't it? Is that okay? So we now have the change in T. This is now change in torque, isn't it? This is change in torque, and this one is change in magnetic flux density, isn't it? This is change in B, and this one is change in current. Are you together? Change in current. So what do we need to do? What do we need to do for us to get change in T? We need to get this partial derivative, we need to get this change in B, we need to get this partial derivative, we need to get all these values, then we perform those operations, isn't it? Are we together? So let us start with the first one, partial T partially with respect to B. Meaning when you are differentiating T partially with respect to B, you must have that equation, isn't it? What is our equation? T is equals to 1000 Bi, isn't it? So we want to differentiate T partially with respect to B. So when we are differentiating T partially with respect to B, only B is a constant, isn't it? Anything else is only B is a variable, anything else is a constant, isn't it? So it means 1000 I is a constant. If you differentiate B, you get 1. So what do you remain with? 1000 I. Senor, what about, meaning we found this partial derivative, isn't it? Now, what about this partial derivative? What about if we differentiate T partially with respect to I, isn't it? So if we differentiate T partially with respect to I, what do we get? Meaning when we are differentiating with respect to I, only I is a variable, isn't it? So it means 1000 B is now a constant because we are doing partially with respect to I. Senor. And if you differentiate I, you get 1, isn't it? Then you remain with 1000 B. Are we together? And what have you been told? You've been told B is 50 and I is 10. Meaning where there is B, you put 50, and where there is I, you put 10. So if B is 50 and I is 10, then it simply implies that partial T with respect to B is what? 1000 I. 1000 times the value of I, you get 10,000. Then partial T with respect to I, what do you have? T partially with respect to I, what do you get? 1000 B, meaning 1000 times the value of B. 50,000. So what have we done? We found this partial derivative, we found this partial derivative, isn't it? Meaning for us to get this change, this, and this are what are left. Are you seeing? So you go, what is change in B? What is change in magnetic flux density? Magnetic flux density, you are told, B rises by 2 Tesla. Rising means increases, isn't it? And something is created is positive, isn't it? Meaning change in B is positive. To rises means positive, increasing, isn't it? And you'll be told change in I, current, change in I. You'll be told the current is dropping by 3 amps, meaning that change is 3. The change in between. That means dropping by 3 amps means when the current was 10, the next will be 7, the next will be 4, the next will be 1. So the change is in between is -3. That is what it means. Are you seeing? It is dropping, meaning 10 plus -3, you get that 7 plus, it is dropping, negative. Are you getting the concept there? So the change in current it is dropping by 3, dropping means -3. So it means we found this partial derivative, we were given this change, we found this partial derivative, we were given that change. So what we do is to perform this product, and add them, isn't it? Meaning what we do, we just substitute to get the change in T, because the change in torque is what they require. This is the partial change in T, isn't it? So what is change in T? So change in T is equals to base times base. What is partial T over partial B? You found it to be 10,000. It is times change in B. Change in B you found to be positive 2 is just 2, isn't it? Then it is plus partial T with respect to I you found to be 50,000. Then it is times change in I you found to be -3. So if you perform this operation, what do you find to be the approximate change in torque? What is required? What do you have? This is -130,000. What am I saying here? You have -130,000. So negative means what? Decreases, isn't it? So what is the change in torque? The torque is dropping by base, because negative means a drop, positive means a rise according to the equation. Use what is according to the equation, isn't it? So change in torque is -130,000, and the torque is in Nm, isn't it? So you come and change the torque. Torque does what? Drops by 130,000 Nm. Are you seeing that? Newton meter. Because that negative means drop. So the torque is dropping by -130,000. It's dropping by 130,000. Negative, the word drop is taking care of the negative, isn't it? Are you together? And you've dealt with that kind of problems. It means these problems are very simple. All you need to know is the total derivative, and from the total derivative, you are able to get either change or rate of change, what is required, isn't it? Good.